All right, so looking at our next set of examples, now we've got a full out expand. This one says rewrite this thing as a sum or difference of logs. So first thing is we need to focus on what the outermost operation is. In this case, that's the fraction. And then within that fraction on top, there's some multiplication. So we can do that as 2 steps or 1 step. It's whatever you're comfortable with. I'll go ahead and do 2 steps on this one. So we can rewrite this as the natural log of x to the 4th y minus the natural log of 7. And then that x to the 4th times y, we use our product rule. So that will be the natural log of x to the 4th plus the natural log of y minus the natural log of 7 still. And then we have one more step now because we have the power down rule. That's what we're going to do. So now we have 4 times the natural log of x plus the natural log of y minus the natural log of 7. So the fraction was our outermost operation. Once that was done, we had multiplication as the outermost operation. Once we'd broken that, now we had a thing with an exponent and nothing else being added or subtracted to it. If there was some sort of addition or subtraction, that power is not coming out. It's not going to power down because it's not the outermost operation. All right. But when you get really comfortable with these, you can make the jump to here or even here. All righty, so this one powers abound. So let's start with, I've got stuff on top. So we'll have the log of x squared, and that's times, so I'm going to split this now, plus the log of y cubed. And then that z to the 4th is on the bottom, so it will be minus the log of z to the 4th. And now each one of these, the power comes down just in front of its own log. So this log of x squared will become 2 times the log of x, plus now it will be 3 times the log of y, minus 4 times the log of z. So the more you practice using the rules, the more quickly this becomes, and the less you will have to think about it when you have to use it later as a skill. So I know you don't want to hear this late in the semester. You should practice this, but you might want to consider it just a little. All right. And then we have the log of the square root of x. So just like we saw in some of the exponential problems, square root here is awkward. So we're going to change it to its numeric exponential form. So remember, square root, because it cancels out squares, it's the same as the number that would cancel out multiplying by 2, which is a half. So the square root of x is the same as x to the 1/2. And then we use our power down rule. And so now we have 1/2 as the coefficient in front of log of x. So if you see a radical, don't freak out. Just remember, oh wait, that's just a fraction. Like this one here. Again, don't freak out. We know what a cube root is. So I have my x squared. Cube root cancels out cubing. To cancel out multiplying by 3, I would multiply by 1/3. So the cube root is the 1/3 power. Now remember, we have a base raised to a power that is then getting raised to another power. Those powers multiply. They're close enough to multiply. All they have is the condom of mathematics in between them. There's not another base. Multiply here. So 2 times 1/3 will be 2/3. And now we can just bring that whole 2/3 down as the power. 2/3 times the natural log of x. And now they decided, let's make it crazy. All right. I hear you. I see you crazy. I got you. Okay. So that's 64. Yeah, let's go ahead and mess with it real quick. 64 is 8 squared. But 8 is 2 to the third. So 2 to the third squared is 2 to the sixth. So that's what I'm going to write in my first step here. Log base 6 of 2 to the sixth. There's our 64. Plus log base 6 of x to the third plus log base 6 of 4x plus 1 in parentheses. If you don't put the parentheses, people will assume wherever the multiplication is, that's inside the log. But if you wrote a plus after that, they will assume that is outside the log. If you're ever getting confused, feel free to go back and drop parentheses around what you know was inside the logarithm. So that way you're not confused looking at it later. Minus, because we still hadn't actually written everything down, we still had that 2x minus 1 from the bottom. Now the only thing left is dealing with those powers. So that log base 6 of 2 to the sixth, the sixth is going to come down, so it'll be in front as a coefficient. So it's 6 times log base, log base 6 of 2. My brain was like, 6 and 2 would cancel and it'd be a 3. Not with logs. Like there might be a way to do that canceling, but the fact that it's a 6 outside and it's log base 6, pure coincidence. We don't have any way to really interact those in a useful way. It is not 6 times that cancels out a log. It is 6 as a base with everything as a power. All right, our next one, that 3 is going to come down. That'll leave log base 6 of x. And then these other two are staying as is. I cannot break the log across addition. And I cannot break the log across subtraction. So for those two, that's all she wrote. For those others, I managed to pull some powers down. Cool. But that's it. That is fully expended. All right, we got one more. This one, for some bizarre reason, decided, hey, let's put a big square root. All right, so before we even deal with the natural log, we're just going to deal with rewriting that in a form that makes sense with what we know we have to do next. So the x minus 1 is under the square root. And the 2x plus 1 squared is under the square root. I can split a square root across multiplication. So I can break the square root to the x minus 1 and the square root to the 2x plus 1 squared. So that is 2x plus 1 squared to the 1/2. So squared to the 1/2, 2 times a half is 1. Yes. So this is just going to be 2x plus 1 here in a minute. So let me just kind of write that. And then on the bottom, x squared minus 9. We could leave it like that. It's kind of arguable about which one's simpler, but since we're expanding, x squared minus 9 is actually factorable. That is our lovely difference of squares. So x and x, 3 and 3, 1 must be plus and 1 must be minus. So that is our rewritten log, but we haven't used any log properties. We were just using exponent properties so that now that we use log properties, it won't be so ugly. And yeah. All right, so our first one, the natural log of x minus 1 to the 1/2. And we will bring the powers down, but I usually separate dealing with powers separate from product and quotient rules, because the powers are usually associated with things that are in the big product quotient mush. All right, so then it will be plus the natural log of 2x plus 1 minus the natural log of x plus 3 and minus the natural log of x minus 3. So there's our 4 pieces. Our last step is just bringing that 1/2 down. So even though the 1/2 came down, I still need my parentheses around the x minus 1. The same with all of these. If I drop the parentheses, then it looks like I'm adding 1 outside the log, and then it can really mess with your calculations. So when in doubt, write them out. Hey, that rhymed. So that would be our fully expanded natural log for that one. All right, what we're going to practice next is condensing, and then we have the change of base at the end, which is useful for calculating.